This video is on the objective find the unit vector. Now this is find the, if you're given a vector, you're asked to find another vector that points in the same direction but only has, a length of 1 unit or a magnitude of 1 unit. That's what they mean by find the unit vector. And this is the second video on this. I'm hoping you watched the first one because I'm just going to go right into working the problem with a little less explanation than I did in the first video. Alright, so if you want to see more about the topic, click on More Instruction, look at their videos, their notes, their examples, and hopefully those help you. Alright, so here we're given the vector, W has components 1 and -5. We're asked to find the unit vector, the vector that's 1 unit long that points in the same direction as W. Okay, so remember, in order to do this, I need to know how long W is. So W has components, one unit right, and then 5 units down, right? Negative 5 for the second component. Now, if the length of this vector is 1, then I can stop. I mean, this would be a unit vector, but it doesn't look like it's going to be, right? Because if I find the magnitude of W, the length of W, that's the square root of the first component squared plus the second component squared, and that's 1 plus 25, the square root of 26 units long, which is not 1. Right, that's definitely bigger than 1. This is a little bit bigger than 5 units long. Alright, well, if this vector is a little more than 5 units long, right, it's the square root of 26 units long, and I want a vector that points in the same direction but is only 1 unit long, I just take W and multiply it by the reciprocal of its length, or you could say W divided by the magnitude of W, and this will give me a vector that's 1 unit long and points in the same direction as W. And you can draw these if you want on the coordinate plane. I'm not doing that this time. So 1 divided by the square root of 26, there's your 1 over the magnitude of W, times W. And hopefully you recall how to do scalar multiplication, right? This is a scalar out here, a number. You just multiply each component by that number. So I'll call this U for unit vector. Right. First component, 1 divided by the square root of 26. Second component, -5 over the square root of 26. And there you go. This is a vector that has a magnitude of 1 that points in the same direction as my first vector W. Now you might be asked to you might see in the options that they're going to be rationalizing the denominators. So I would multiply both of these by the square root of 26 over the square root of 26. So I have the square root of 26 divided by 26 for the first component, and then -5 times the square root of 26 divided by 26 for the second component. And this is what their final answer is. All right. Well, let me see if that's an option, but I'm pretty sure. Right. Yeah, right there. Right. There's a vector with 1 unit long and points in the same direction as W. Again, very simple. Just find, if you remember how to find the length of a vector, just divide by that length. It's that simple. Divide each component by that length. Okay. So again, hopefully watching me do this, looking at the more instruction when you need to, reading the answer explanations when they come up, and I'm hoping all this stuff helps you out when you work on this material on your own. And thank you very much for watching.